So this is number 4 from today's worksheet. So, okay, our first step, if we see it written as y prime, we want to write it in proper notation, or the Leibniz notation, which helps us with integration of dy over dx. So if needed, that's your first step. Then we want to separate, meaning get the y's on one side, get the x's on the other side. And normally I like having the y's to the left, so I can just cross multiply in this case. And I have x plus 1 dx. So once we separate, and y's on the left, x is on the right, we can then go ahead and integrate. And so when I integrate y, I get y squared over 2. And when I integrate x, we get x squared over 2. Integrate 1, we get x plus c. Before I go any further and get y by itself, I can go ahead and figure out what c is, because we're looking for it at this point, 0, negative 2. So wherever I see an x, I can plug in 0. And wherever I see a y, I can plug in negative 2. And so negative 2 squared is 4 divided by 2. I get 2 equals c. So I know what my c is. So I'm trying to get this by itself. So right now, I'll rewrite this. But now instead of just c, I will write 2. Okay, now let's get y by itself. So I need to multiply everything by 2. So I have y squared equals, when I multiply this by 2, I just get x squared plus 2x plus 4. And now I need to take the square root. Y equals plus or minus the square root of x squared plus 2x plus 4. However, again, we're looking for the solution at the point 0, negative 2. So notice y is a negative number. Therefore, I'm only looking for the negative of this. And so, final answer. Because we're looking at the solution at this point, I know that y equals must be negative. So out of the radical, I'll never get a negative. Therefore, the outside must have the negative. Negative, whatever this is.